Hello, welcome to my blog, and today we are do a different thing. I didn't prepare a post like I used to, um, but today we are talking about uh, computer vision and specifically regarding the face detection technique using Viola-Jones algorithm. So like you can see, we have the Viola-Jones algorithm, and we have, this is the Paul Viola, this is the Michael Jones. um, this kind of technique was created in 2001, and after this continually use it in the face detection, in videos or images itself. So the algorithm is divided in two phases. One of the phases is training, another phase, another is detection, right? So we have here an example of an image of a person that we have a face, right? The first thing the algorithm prepares is the transformation of the image in grayscale. This is the first step. So after that we have some kind of a filter. It's possible to configure the size of this rectangle that will passing by from the left side of the image until the right side of the image, and line by line of the image also. So like you can see over here, for example, so we have different for example, when the algorithm detects, okay, this is a face, the algorithm marks that region of the image like a face, right? And continues so on the progress of the detection, right? So for example, this is a additional reading that is pretty good. The original paper from 2001, Paul Viola and Michael Jones, and we will be talking about the Haar-like features liked, that this algorithm uses this kind of features to detect the face. So it's based on Hungarian mathematician called Alfred Haar. This we have that to give all the credits to him, because this algorithm uses this pretty much features to detect the variation between, for example, white and after that black. So this variation in white and black are the opposite in the horizontal in black and white, or in vertical white and black and white, and the opposites. It's true, like you can see over here in edge features. This is our the features detectors. we have another models also like this, and we have the blank white space, and we have the black space and white space also. This is a vertical line. In terms of horizontal line, we have the white black white pattern. Well, over here this is a 4 rectangle features, Haar-like features also. We have these 3 kinds of possibilities to detect the variation, and of course that in mathematical terms, in the background, the algorithm is detect the difference between the big difference between they call it the variation, a big variation, right? So over here, like the mouth of this person was detected by the algorithm, like you can see. So we have this part of the face also, and nose and eyes also. So for example, we have different variations of the image over here, like you can see on the nose. For example, we have the white, and after that a black, a dark area in the image that will be dividing into different small sub areas that will help to determine the variation between these parts. And we have the white region over here, and we have the dark region over here, and we do some kind of operation that is the black minus white region equals 0.402. This is a mathematical calculation behind. And another important feature also is called integral image, that is possible to see. For example, we have a matrix. Every image is a matrix, right? You can represent an image like in pixels, dot, and we have some values of these pictures that will be represented by this matrix, and we inside of this matrix we have a specific region. So this specific region, we need to think in terms of how to accelerate the processing, computing processing of the machine. So we need they taught this kind of technique. And for example, if you see the matrix or the left matrix, you will see entire numbers for the image, and will be represented a lot of numbers. And on the right region you see just on one number. For example, over here, this just small square will represent 1, 2, 3, 4, 5, 6 numbers. Just one number will be representing this area of the image. And we have over here another part of the image, like you can see over here, that will be represented just for 1, 3, 4, the number. This technique is called integral image, that is used by the Viola-Jones algorithm. And I will show you the demonstration of the face detection algorithm right now. So over here we have the Anaconda. Anaconda is the one of the best and most famous framework to use in data science projects, machine learning, deep learning. And I'm using Spider, that is a great IDE to do this kind of operation. And we have here the code of this algorithm, right? One important information that I need to give you is that I'm using a library called OpenCV. So this is an important library that you can have access of different functions to deal with computer vision itself, specifically about images and videos. So we have here the code, right? And like you can see, it's not an extensive code because we are using templates, and it's called cascades over here, and we have to use a function to call the OpenCV library to capture the face detection, like I will demonstrate right now to you. So like you can see, this is my face, and I'm talking about the algorithm itself. So it's possible that to see that I'm moving my head and the left to the right, or up or down. So the algorithm continues detecting my face all the times. And like you can see, the green area is the my eye that was detected by the algorithm itself. So it's pretty cool if you the application of this kind of technology is amazing, because you can try to identify in online system some faces, and it can be used in a lot of applications like security, for example, and the police. It's possible to use in some investigation, and this technology is already used for some like FBI and CIA, that helps a lot in the try to surveillance of some environments, and try to recognize some violent people, and try to eliminate the possibility, for example, for terrorist attack. So it's all I have for today, and I hope that you enjoyed the Viola-Jones algorithm to face detection, and it will be available in my GitHub, and you can do the download with the instructions to install the OpenCV in your Anaconda system, and you can try by yourself. See you until the next video. Cheers.